So our next speaker, David, is from Plex Labs, and David will be talking about cross-chain applications, pardon me, or rather omni-chain. Hey David, how are you?
Hey everyone, what's up?
Cool, cool. I think we're good. Hola, Arta. Good to see you in the chat. Hey, Nestor. Good to see you again. Awesome. David, feel free to get your slides up and ready. Cool. And we can prepare for our second workshop of the day. Anyone in the chat, if you haven't registered yet, or if you're looking for resources, please don't forget that the Hackpack is here. I will drop the link quickly. Awesome. So Hackpack here. And amazing. We can see your slides. Everything is good. Yeah, David, why don't we get stuck in straight away?
Awesome. So hey everyone, my name is David, and I'm a developer from the Plex Labs team, and I've been a core contributor for Canto since we launched, and work primarily in 3 different areas. So one is the Canto FPI, which is the free public infrastructure, which would include like the Canto lending market, the DEX, staking, and governance. Also the Canto IO front end, which is the main way users interact with the main protocols that Canto has to offer. And then also mainly the integrations with LayerZero, which I'll talk about today. So today I'll cover a new primitive on Canto called the application specific dollar, how it works, why it's useful, and a bit on how we integrated this with LayerZero to incorporate cross-chain functionality and availability of the Canto lending market yield across multiple networks. So I guess just to jump right in, before getting into the actual application specific dollar, I want to go over like the basics of the Canto lending market and the design of Canto stablecoin note. So to begin, the Canto lending market, or I'll just refer to it as CLM, is an adaptation of the compound V2 lending market. So it's operated with an automated market maker, which users can carry out borrowing and lending transactions using underlying liquidity pools. So this means that there's no forced peer-to-peer transactions, which reduces wait times and allows the entire system to be self-sustaining. So assets that are supported are integrated with C token contracts. So these are basically just contracts which allow users to mint, redeem, borrow, and repay tokens. So when a user actually interacts with the protocol, they're really interacting with C tokens, whether they're doing these like supplies or borrows. And in this lending market, there's 2 ways to earn yield. One is through the supply interest rate. And this is done just by holding these C tokens. And these accumulate interest from borrowers over time as they repay their borrows. So since each C token market has a borrow APR, that means that each C token in the supply market will become convertible to an increasing amount of the underlying asset. Also is through distribution APR, which is from the protocol itself, and this is rewarded in wrapped Canto. And this APR is a fixed rate that's set by governance, and each C token in the market has a different distribution APR depending on the proposals that are passed and the governance rate. And finally, these C tokens, like I said before, they kind of act as receipts for the underlying tokens that are supplied. And these are also used for collateral for borrowing. So for example, each token would have a collateral factor, and say you supply 100 USDC, and this has a collateral factor of 90%. This same user can now borrow 90 USDC worth of assets from the borrow side of the market. These will accrue interest, and these would have to be repaid before the collateral can be withdrawn from the market. So that's just a basic overview of like how the Canto lending market works. And then we'll see how we use this with our ASD to gain some yield. So go on to the next slide. So also a brief overview of Note itself. So Note is the unit of account on Canto. So everything in the lending market is accounted for in terms of Note and the price of Note. So Note itself is an over-collateralized currency, which is backed by stablecoins and real-world assets, or RWAs. with its value always rebalancing towards $1 using an algorithmic interest rate. So all note cannot be created, or note itself cannot be created. All of it has already been created. So it must be borrowed from the Canto lending market. This ensures that it's over collateralized and that for every note in circulation, there's at least $1 worth of collateral held in the lending market. So just to talk a little bit about the interest rate. So the way that this interest rate works is that it's automatically adjusted based off of the TWAP price of note, basically the price of note in our decentralized exchange. And this is calculated every 6 hours. So for example, if note is trading under $1 currently, then the interest rate would be raised. And this strengthens the incentive for buying note on secondary markets and lending it to the lending market. And then conversely, if note is trading over $1, the interest rate would then be lowered to make borrowing the asset more favorable on secondary market, or to make borrowing note from the CLM and selling it on secondary markets more appealing. And then C note itself is that token, the C token market that is received when supplying to the lending market. And this will be like crucial for the implementation of application specific dollar. Also, I see in the chat which stables are used as collateral. So right now we have USDC, USDT as the two main stables that are used as collateral. And then for the RWAs, we have like if FBill, IFBill, and like hash note treasury bills. And all three of those are basically just treasury bills. And each of those have like a collateral factor between 80 to 90%. So those are the only 5 tokens that are actually used as collateral. So yeah, this will ensure that note is backed by only assets that are actually worth $1. So now moving on to ASD. So this allows, so ASD, which is application specific dollar. So this is an SDK that will allow anyone or any protocol to create a stable coin that is pegged 1-to-1 with note. So all the yield that this note would generate goes to the creator of this application. So this would be useful for applications like lending markets or DEXs that would take advantage of stable coins that would rather just be sitting in the contract itself, generating no real revenue. The creator can use that to generate note yield. So the creator can also decide to kick back this revenue back to the protocol or back to its users. But this is really up to the design of the developer or the protocol itself. So the ASD contract has basically 3 main functions on top of the regular token ERC20 implementation, which is basically just the mint function, which would mint an amount of ASD tokens while that user provides the same amount of note. Burn, which burns an amount of ASD tokens to the users, and will withdraw the correct amount of C note from the lending market in order to return the user with the same amount of note. I'll get into that a little bit later of how it does that. And then the withdraw carry, which allows the owner of this contract to withdraw any of the yield gained from note supplied into the lending market. And again, the developer can kick back these rewards or do something else with this withdraw carry function to allow others to gain from this yield as well. I also see another question regarding RWA's collateral. How is that managed behind, or is centralized control avoided? Because note may be decentralized, but those real assets are not. So not to get like too far into the RWA itself, but those are centralized. However, the token itself can still be like the token is just a representation of the RWA itself. So the lending market would hold the RWA, and our lending market itself is an approved like whitelisted owner of RWAs. So in terms of like liquidation or anything like that, the lending market would then basically take the RWA from that user. So it would still work in that way. Okay, so for minting ASD, it's a very simple flow, kind of similar to like kind of a swap, but you'll see. So say a user like has note and they want to purchase an ASD token from a protocol. they need to do something with that token, they would just call deposit on the ASD contract, which would take that specified amount of note from the user. And then during this process, the ASD contract would just supply this note to the lending market, which would also internally mint C note. And this is the token that will actually accrue interest. So this C note is returned to the ASD contract. It'll hold on to that. And then the ASD is minted, again, in a 1-to-1 ratio of the amount of note supplied, not the amount of C note that was returned. And then finally, this ASD token is returned to the user. They can now interact with the protocol with it, or other functionality that the ASD provides. Then similarly for ASD burning, it's kind of the exact same flow, just in a reverse order. So if a user has ASD and they want to redeem this for note, they would call burn on the ASD contract. And here's where the calculation is actually made. So the contract would calculate the amount of C note that is needed to withdraw from the lending market in order to receive that same amount of note back. So what this means is that when that C note was initially minted, the actual value of that has now increased in terms of note. So less C note will now be needed to take back that same amount of note from the lending market. And this is basically how the ASD contract will accrue like interest. And this is done with this exchange rate of note, which is an always increasing rate. So then this note is just returned back to the user. Also see, is this only on the Canto chain? So currently, yes, it's on the Canto chain. And then I will actually get into very shortly how we created this as a cross-chain element as well. So this is where we get into with LayerZero. So our main goal of this ASD project was to allow protocols from any chain to utilize this ASD functionality and earn this like note T-bill return from stablecoins across all different networks. So yeah, to do this, we integrated with LayerZero. So very shortly, a quick like brief overview of LayerZero. So what LayerZero has to offer is something called an omni-chain app, or an Oapp, which is basically an application that uses a global ledger to interact and exist as a smart contract on all chains that it's deployed on. So in this image below, you kind of shows the standard flow of how an OFT works, which is an omni-chain fungible token, which is just a standard ERC token, which implements a special debit and credit functionality. So those are the only two functions that are really added on top of ERC20. So what's really interesting about the LayerZero part is also in the middle, which is this security stack, which is another configurable field that developers can apply any access controls that you would normally apply, whether it's pausable, multi-sigs, etc., anything like that. And with LayerZero, you can also choose the size of the security to verify messages across chains, as well as the types of validation techniques that are used. So for example, if one of the validation fails, for example, the message will still not be stopped if the developer has configured that maybe only 2 of the 3 validation techniques must pass. So for this flow right here, what would really happen is that debit would be called on the source chain. These tokens would then be burned from the user's account. The message is passed through the LayerZero security stack. And then credit would be called in the destination chain, which will now mint those tokens to the user. And then how does this actually work? With something called these LayerZero endpoints, which is basically the main communicator between chains and the security stack. So any application, regardless of its usage of LayerZero contract standards, can actually communicate with these endpoints from the source blockchain. So this message, which again is configurable and is actually stored as a message library in the endpoint itself, and the developer would own this library, would be passed through the security stack. Again, this configuration could be the security and the validation needed in the stack itself, but maybe also how the message should be executed on the destination chain. And we'll go over those as well, the different configs. And then once this is passed to the endpoint on the destination chain, any user can permissionlessly execute this message, or it'll automatically be executed by an executor that LayerZero runs on the destination chain. So just to go over some of this like Oapp configuration, that we're going to use a lot of these for ASD, and I'll show you how it works. So some other things that you can configure are block confirmations, which would be the amount of blocks that must be confirmed by the source chain before a message gets emitted to LayerZero. So this could protect you from like reorg risks if the source chain is prone to high frequency reorgs. Again, the security stack, how many techniques should be used to verify messages, how many should pass, how many could fail. More interestingly, you can abstract gas from the users with message execution. So the user would only have to pay in the source chain native token, and it would automatically be swapped for them on the destination chain. And this can be used for execution itself. And even without an executor, anybody can call this function from the destination endpoint with the native gas token and execute these messages, which will bring us to the next point, which is the execution gas settings, which you can specify gas settings on the receive logic of messages. So for example, say you want to mint a token on the destination chain, you could provide the gas limit or the amount of gas required for minting that token. You might also want to provide a secondary transaction, like swapping the token in exchange for another ERC20 token. And this can all be done with LayerZero message composing, is what they call it, which is another transaction that would be run by an executor once the message has arrived. And you could provide the gas and message value for that transaction itself as well. And then finally, you can even add a airdrop value, which is the amount of native tokens you might want to send to a user on the destination chain. And this is something that could help with like onboarding users to get them started with some native gas tokens. You can also configure ordering of messages. So by default, if messages fail, the next ones can still be executed. But say for some reason you're a developer and you have an app that requires specific message ordering, maybe it's a governance application, subsequent messages can actually be paused until the first ones are fully successful. And then finally, you can set the max message size, which is really just to standardize different message structures, which could protect you from overflows, underflows, if messages from the source are not formatted properly. So we're going to use these custom configurations and these LayerZero features to allow ASD to become multi-chain and this note yield-bearing token, which will bring us to the next part, which is the ASD OFT. So this is just the exact same ASD that we just talked about before, but now we're also implementing it and inheriting the OFT functionality from LayerZero. So as a developer, the contract that holds all the minting logic of ASD will live on Canto as an OFT. And this is to ensure that only Note backs it and that all the minting only actually happens with the verified version of Note using the Canto lending market. OFT is the omni-chain fungible token. So it's basically just LayerZero's implementation of ERC20 that will connect with the endpoints and the security stack to mint and burn from one chain to another. So it's basically just a new type of like bridging for a token. So back to the other point. So yeah, all Note would be backed by, all ASD will still be backed by Note because all the minting will be happening on Canto. So all other versions of this token would live on the other chains just as an OFT. So then users can use those as regular ERC20 tokens, and as well as like send those to other chains. And this will allow ASD to be minted from any chain using LayerZero message passing. And we'll do this using a new contract that we built called the ASD Router. And I'll explain this further, which this will basically route all ASD cross-chain messages. And this will help perform the minting and sending of these tokens from each chain to each other. And then I also see, so Note is an ASD OFT. Not exactly sure what that question means. Basically, I'll just explain like the router. Maybe that'll answer the question. So the ASD router is the main contract that the ASD tokens from any chain would interact with in order to allow for a fully decentralized and cross-chain stable token that is fully backed by Canto's unit of account, which would be Note. So coming back to the original flow that we had for ASD. This is the single chain version of ASD, which again just takes a note and will at the end get ASD for the user after it deposits in the lending market. So with LayerZero and creating an ASD OFT, this is kind of what the flow would now look like. So just a quick example, the user would now have, say, USDC on a chain like Arbitrum. They would send this USDC through LayerZero to the router itself, and the router will perform all of that minting logic that we talked about before to get that ASD token. And then that token itself would then be sent back to that user on Arbitrum. So all of this area on Canto would be an atomic transaction, as well as the sending through LayerZero back to ASD. So now we'll look at what actually happens inside the router and how we actually were able to convert this USDC into ASD. So the core functionality of this router is basically to do one thing. It receives stablecoins like USDC. It'll swap it for note on Canto. It'll deposit that note to ASD, which will then mint these ASD tokens. And then it'll then send these tokens to the destination chain, probably where the protocol actually lives. And this can also just be the Canto network itself. So what this means is that if you have tokens on any chain and there's a protocol with these ASD tokens on Canto, you can actually send stablecoins from any of these chains and still get that ASD on Canto. So you don't even really need to have note ever to do this. So yeah, the question is send ASD through LayerZero. So since ASD will also be an OFT, yeah, the ASD would be sent through LayerZero. So it's just going to be a regular ERC20 token. It just also has this OFT functionality, so it can live on all these other chains. So how the actual router basically knows what to do is through the message packet that LayerZero provides. So again, the main functionality is to accept and reroute stablecoins from any chain to the correct ASD version and return those tokens onto the correct chain where they can be used. So from the previous example, a user would send USDC to the router contract, and the packet of this transaction can be seen to the left. And what tells this router what actually to do with the stablecoin is in this bytes message part of the packet, which is just the payload. And the router has this configured structure, which is very rigid for the payload. And this is kind of how we use these LayerZero configurations. So we're going to be telling the endpoints what exactly this message should contain. And here I can see ASD will be sent or minted on the destination chain. It's always going to be minted on Canto. So all ASD, the core ASD function for any protocol will always be on Canto. And then all the other versions of it as an OFT would be deployed on the other chains. So all the minting logic is done on Canto. So with this OFT compose message, this is basically what tells our router exactly what to do with these stablecoins and how to mint ASD. So it has all these main properties. One is the destination EID, which is basically just a LayerZero ID, which will tell the router which chain that the ASD tokens must end up on. The destination receiver, which will most likely just be an address of an EOA to send these tokens to, just a wallet address. The destination ASD address, which will be that address of the ASD on the destination, which again would be implemented as a regular OFT. The Canto ASD address, which a lot of times would be the same address if it's two EVM chains. But this will tell the router exactly which vault that it would need to deposit this note into in order to mint ASD, since all the minting logic will be on Canto. And then the minimum amount of ASD needed for this transaction to not revert. So this is just for like simple swap slippage conditions, since the price of note may not be exactly $1, and the USDC that's sent has to be swapped for note. This slippage basically just ensures that a user isn't making a trade that they weren't intending to make. And then the Canto refund address, which is, I'll get into the refunds as well, but the Canto refund address would be the address that any tokens in the case of transaction failure would be refunded to. And then finally, the last one is the fee for the send, which is basically just the native gas in terms of Canto, that the native token would need to be sent back through LayerZero in the case that the ASD tokens are bridged to another chain. So if ASD lives on Canto and you're just trying to get them on Canto, this message, like this fee for send, would just be 0, since there won't be any other bridges. And then finally, the actual refunding part of all of this. So as we mentioned in the previous slide, there's multiple cases where the ASD router might not actually be able to perform certain tasks. For example, that slippage for a swap. So in this case, we actually don't want any composed functions to revert, since the message would then be stored in the LayerZero endpoint, and the user would actually risk not receiving their funds. So a big part of this contract, including even the audit that we just did for it, was to make sure that this contract never reverts. So we include a lot of different safety checks. So for example, if the message itself that's passed the router is not formatted properly, this function would always revert, which we can't have happen. Otherwise, the tokens would always be locked. So in this case, the USDC that was actually transferred will just be immediately refunded to that user on Canto. This is to ensure no loss once again. And yes, LayerZero is a bridge. If the token sent to the router is not whitelisted version of USDC, for example, if this isn't a version that we can swap with, or if this isn't even a version of USDC that we've whitelisted, then that version will just be refunded to the user on Canto, since it won't be like applicable to swap into Note. Like I said before, if the token swap fails itself because of slippage or price movement of Note, again, that USDC would be refunded. And then here, in the next 3, other tokens would be refunded. So for example, say the Note is swapped, and now there's an error minting ASD for some reason. Say the message contains the wrong ASD address, and the minting itself just fails with the lending market. Since the Note has already been swapped for, we would just refund that Note to the user on Canto itself. From here, the user can just redeposit that back into the correct ASD vault, and bridge their tokens back that way. And then finally, if the user doesn't send enough native funds for the layer bridge transaction, if they accidentally input a value that's too low, then the user will just be refunded the ASD version. Since it was already minted, it'll be refunded that token on Canto itself. So basically, all refunds will be happening on Canto, and any native gas that was also sent to be swapped for and to be used in this transaction are also refunded to the user. So this basically ensures that no funds are lost because of any errors that could happen inside the router. So that's basically how the router works and how we use this to allow ASD to become a multi-chain contract. And that's basically all. So if there's any questions, hopefully you gained a little bit of better understanding of Canto's new ASD protocol, how we kind of integrated it with LayerZero to allow any chain to get note yield. And yeah, I'll reserve the rest of the time for any questions. So I see one is, cannot enough fee cause the refund? So yeah, if there isn't, like, if LayerZero is, if the price gets, like, if the price of gas goes up, for example, which would cause the bridge itself to fail, then we would just refund the actual gas that you wanted to send in terms of Canto, as well as the token. And then you can retry bridging. So again, with this contract, there's no way a user will lose funds, but there are chances that the ASD is not actually minted. So the user would just need to retry. So what chains are compatible? So basically any chain that LayerZero supports. So they have it on their site as well. They basically support like just about every single EVM chain. I do believe that they also support like chains like Aptos, so it doesn't have to be EVM chains. But they basically, any chain that is compatible is what LayerZero would host an endpoint on, which is just about every chain that I can think of.
Cool. Any other questions? I can see the pause typing. Great. Well, I think if those are all of the questions, and good to see you guys engaging throughout the session. It was really well explained. Thank you, David. If you guys have any other questions as well, where is best to contact you, David?
I can just put my Telegram in the chat. So this would be my Telegram. Oh, I don't know why that keeps happening. Oh, this is weird. Okay, there's an @ symbol before it, but I guess.
Great. Yeah, perfect. Awesome. Well, to everyone in the audience, thank you so much for coming along. I will put your Telegram in the chat as well. So in all of the channels that we're announcing information for this hack in. But yeah, once again, David, thank you so much for coming along and giving us that wonderful explanation and kind of going through all the basics. I know we have a range of different participants here. Some people are new to Web3, some people are exploring new things. So it's really great to have you come and explain everything very well. And it's great to see everyone in the audience have great questions.
Yeah, awesome.
Okay.
Thank you so much. And I'll be around for like the office hours that we're going to be setting up, and for anyone who needs help actually integrating any of this with their protocols that they're building for the hackathon. I'll be around in the chats and the office hours.
Perfect. Cool. Well, thank you so much. Looking forward to those running, and I hope everyone in the chat in the audience is too. I will send information on that out soon. All right. Well, thank you all so much, everyone. And thank you so much, David, for speaking with us today. Right.
Thank you, guys.
See you. Bye.